circles. Here we go. Hold on. Hopefully there's no glare. Good, there's no glare. Okay, I'm looking at where is my sine value, the square root of 3 over 2. So forget this for right now, all the rest of this. I'm just looking at this. Where is my sine value, the square root of 3 over 2? Where is y, the square root of 3 over 2? Well, it's right here, isn't it? 60 degrees pi over 3. So my reference angle is 60 or pi over 3. A lot of people are asking, why do we need to know the reference angle? Here's where you need to know. So first, place your reference angle. Second, place your reference angle in the correct quadrants for the sign. Should I see that sign is bolded? Of the answer. In other words, where is sine negative? Where is sine negative? Well, sine is negative in this quadrant here and this quadrant here. Okay, so a little note here. Each trig function has 2 positive quadrants and 2 negative quadrants. So there should be 2 answers unless theta is on a quadrantal. This means that trig functions are not one-to-one. But we'll get into that a little bit later. Don't worry about this. Okay, so again, there are two places where this thing is going to happen. Now think about this for a second here. If your reference angle is 60, and your reference angle is 60, what are the measures of those angles? You've got 180 plus 60, which is 240. Then you got 360 minus 60, which is 300 degrees. Or you could call it pi over 3, right? If this was pi over 3 and pi over 3, you have 4 pi over 3 and 5 pi over 3. Here's what this is asking you. It wants to know, where is sine negative square root of 3 over 2? Where is sine negative square root of 3 over 2? Well, it happens in 2 places. One's here and one's here. Alright? So this is where we're getting into using our reference angles. So cotangent, the first thing I need to do, cotangent is the square root of 3. Where in the world is cotangent square root of 3? Out of just these guys here, let me do it this way. Where is cotangent going to be square root of 3? Remember, cotangent is x over y. So it's obviously not 45, but if you put this x over this y, no, that's square root of 3 over 3. What about this x over this y? Hey, there we go. Square root of 3. So alpha here is 30 degrees. Or, since we're doing it in radians, or pi over 6. Now, from here, very simple, from here, place your cotangent where cotangent is positive. Cotangent is positive in the first quadrant. Cotangent is positive in the third quadrant. That means this angle and this angle, your reference angles here, are 30 degrees and pi over 6. So theta then is going to be 30 degrees for quadrant 1. 180 plus 30 is 210 for quadrant 3. Or in radians, you've got pi over 6 for quadrant 1. And if this is 1, that's 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. Okay? Last one here. 20 says cosine of theta is negative 1. Where is your cosine negative 1? Where is the x value negative 1? Well, it's a quadrantal. The only x value on this thing that gives you a value of negative 1 is here. It's a quadrantal. There's only one answer for that. 180 degrees and pi. So I'd like you to label that there quadrantal. Alright? So if you think about this, a little side note here. Notice that it says cosine is -1, right? Now think about this. Here cosine is 1, here cosine is -1. Here tangent, or excuse me, sine is 1, here sine is -1. But is there anywhere else on this graph where one of your trig functions would give you a value of 1? Is there anywhere else on the graph, apart from the quadrantals, where you're going to get a value of 1? What if you put this y over this x, or this x over this y? Wouldn't that give you 1? So, if I had the tangent or cotangent of pi over 4, or 45 degrees, that could be 1. So keep that in mind. You're not always looking for a quadrantal when it says 1. Okie dokie. Make sure you hang on to these, and we'll cover some more when we get into class.